Assalamu alaikum. Welcome to the fourth and last part of the ANN series. Today I am going to teach you how to get the data for the ANN training from the Simulink model. Friends, most of the times the basic or conventional model of any system or power system is designed in the Simulink. This conventional model mostly uses PI or PID controller. Now suppose we want to use the artificial neural network as an intelligent controller in that model to improve its performance. To do this, ANN requires the data for its training. For this purpose, we have to get the data from the Simulink model and shift this data from the Simulink to workspace so that we can perform its training using the ANN. It may be noted that this technique can be used for any model related to any field. First, you must notice that whenever and wherever PI controller is used in any model, that PI controller can be replaced with ANN controller. Therefore, this ANN tool is very useful and can be applied to thousands of the research topics for the completion of master and PhD research. Now let's start. To get the data for the ANN training from the Simulink, the first requirement is that we must have that conventional model of any system. For your convenience, I am considering the simple automatic voltage regulator model of the power plant as shown here. On this topic, I have already made the video, namely how to design automatic voltage regulator model of thermal power plant using the transfer functions in MATLAB Simulink. Therefore, if you can watch this video and apply the ANN in this model, then this model can be used for your master research or one of the PhD objective. Now just look at the model. It may be observed that in this model we are using the PID controller. Let's check the voltage graph using the PID controller, run the simulation and double click on this scope to see the voltage graph of this model. Now suppose we want to replace this PID controller with artificial neural network based controller. For this purpose, ANN requires the input and output data of the PID controller for its training. This requires the shifting of PID controller input and output data from the Simulink model to the workspace. For this purpose, just go to Simulink library, then go to sync. You can see here 2 workspace block is available. Take this block and bring it in the model. Connect this block here. Double click on this block. A window will open. In the variable name, write input because this is the input to the PID controller. In the save format, click on array and click OK. Similarly, to get the data for the output, just copy this block and paste it here. Connect this block here. Double click on this block. In the variable name, write output. In the save format, click on array and click OK. Now just run the simulation in order to shift the data from the Simulink model to the workspace. Now come to the command window. You can see in the workspace section, we have input as well as output data. As we have received this input and output data, now we can perform the artificial neural network training by using the MATLAB program or GUI tool as discussed in the previous videos. You may choose any method of your choice. For the convenience, I am using the ANN training using MATLAB program as shown here. It may be noted that you can use the same program as discussed in the previous video. Just change the first 2 lines of the program as shown here. Now to start the ANN training, just click on this run button. It will automatically start the ANN training. It may be noted that ANN training is a complicated process and takes a lot of time. Sometimes it may even take days to complete the successful training. Therefore, in this video, I am just considering the training up to 1000 iteration only in order to show you the whole procedure. However, successful training may require lot of time. You can use it if you want. Let's see what is the regression curve for 1000 iteration. For this purpose, just click on this regression. It will show the regression curve for the ANN training. It may be noted that regression is equal to 0.966, which is less than unity. The criteria for successful ANN training is that regression must be equal to 1. Furthermore, it may be noticed that training data is also not on the straight line, which shows that its training is not successfully completed. Friends, as my intention is not to perform the successful training, but my intention is to teach you the whole process. Therefore, I am using this data in order to teach you the whole procedure. Now look at the workspace section again. You can see here net block is available, which is the trained artificial neural network. Now we have to shift this trained ANN model from this workspace to Simulink. For this purpose, we have the MATLAB command known as gensim command. Therefore, write this command and press enter. You will see that MATLAB has shifted the trained ANN model from the workspace to the Simulink. Now take this trained ANN block from here and bring it in the Simulink model. Remove this PID controller block and connect this ANN block between these two terminals. At this stage, our model is completed. Now we can run the simulation to check the performance of the ANN controller. Click on this run button to run the simulation. Double click on this scope to see the voltage graph. It may be observed that ANN has tried its best to provide the smooth response. Now let's compare the response of PID controller and ANN controller. To do this, just copy this whole model and paste it here. Now replace the ANN controller with original PID controller. In order to combine the graph of both PID and ANN controller, we need multiplexer block. Take this block from here and bring it in the model. Connect the first port with the ANN controller line and connect the second port with the PID controller line. Copy this scope and paste it here. Connect it with the output of the mux. Now run the simulation again. Double click on this scope. It may be seen that now both graphs are combined. Therefore, we can compare the performance of both controllers. The blue color shows the response of the PID controller, whereas yellow color shows the response of the ANN controller. It may be observed that in this situation, the response of the PID controller is better than the response of the ANN controller. It is because we have not performed the successful training of the ANN. When the training of the ANN will be successful, then the response of the ANN controller will be better than the PID controller response. Friends, in this video I have discussed how to get the data for the ANN training from the Simulink model. After that, we performed the ANN training and again shifted the trained ANN model to the Simulink. In the end, we tested the performance of the ANN controller and compared its response with the PID controller. By repeating the same strategy, ANN can be implemented for any model related to any field in order to complete your master or PhD research. That's all for today's tutorial. I hope you really enjoyed this tutorial. Friends, I upload many videos based on various topics of power system and motivation on regular basis. Therefore, don't forget to subscribe my channel in order not to miss my latest videos. And don't forget to share my videos with your friends and class fellows so that they can also get benefit from these videos. Thank you very much.